The most impressive part isn't just the machine itself, it's the entire manufacturing system behind it. The production technology Tesla has developed is operating on a level that no other automotive factory has reached. As 2026 began, Tesla made a surprising change inside its Fremont factory. Instead of adding more industrial robots, the company removed hundreds of them from the production line. By the end of 2025, over 1,000 robots were responsible for welding, painting, and assembling vehicles. But Tesla decided that many of those machines were no longer necessary. According to Elon Musk, the company has created a completely different way of building cars. Rather than relying on countless robotic arms, Tesla is introducing its own next-generation manufacturing technology, something that has been under development for years. At the center of this transformation is the fourth-generation Giga Press. Designed specifically for Tesla's upcoming vehicles, including the Cybercab robotaxi, this enormous casting machine is built to deliver record-breaking production capacity, while operating with the speed and efficiency normally associated with consumer electronics manufacturing instead of traditional automobile assembly. That immediately raises an interesting question. If Tesla plans to build smaller, more affordable vehicles, why would it invest in an even larger gigapress? What is Elon Musk trying to accomplish, and what advantages does this new machine provide? Over the next few minutes, we'll explore Tesla's manufacturing strategy and explain why this technology could reshape the future of vehicle production. Many people think the gigapress is simply an oversized industrial machine, but that's only a small part of the story. Its real significance lies in how it changes the entire manufacturing process, giving Tesla a competitive advantage that many established automakers are still trying to match. The journey began during the development of the Model Y. Tesla wanted to replace dozens of individual metal parts joined together through welding with one large aluminum casting. The concept sounded simple, but there was one major obstacle. No existing machine could produce a casting of that size. Elon Musk contacted leading die-casting manufacturers around the world in search of a solution. Most companies were unable to meet Tesla's requirements. However, one Italian manufacturer, Hydra, had been working on an extremely large high-pressure die-casting system. Its technology turned out to be exactly what Tesla needed. That breakthrough eventually became the gigapress. Today, gigapress machines produce some of the largest structural sections used in vehicles such as the Model Y and the Cybertruck. The process starts by heating an aluminum alloy inside a high-temperature furnace until it becomes completely molten. Once the metal reaches the proper temperature, it is transferred into a precisely engineered steel mold designed to match the exact shape of the component being produced. The next stage is the most important. Under tremendous pressure, the molten aluminum is forced into every part of the mold, filling even the smallest details. This helps eliminate weak points, air pockets, and manufacturing defects while ensuring the finished casting has exceptional strength and consistency. After the mold is completely filled, the cooling phase begins. The aluminum gradually solidifies until it forms the final structural component. Achieving this requires extremely accurate timing. If the metal is injected too quickly, trapped air can create internal voids that reduce strength. If it's injected too slowly, portions of the aluminum may begin to cool before the mold is completely filled, ruining the entire casting. Maintaining the correct temperature throughout the process is equally critical. Tesla's cooling system is carefully designed to keep conditions as uniform as possible, ensuring every casting meets the company's demanding standards for strength, dimensional accuracy, and reliability. Once the part has solidified, automated equipment removes it from the mold, trims away excess material, and sends it through detailed quality inspections before it moves on to vehicle assembly. The advantages extend far beyond faster production. By replacing dozens of welded pieces with a single large casting, the gigapress creates lighter and stronger vehicle structures while increasing rigidity. At the same time, it reduces manufacturing complexity, lowers labor requirements, and shortens overall production time, all through a single manufacturing innovation. Tesla no longer has this technology entirely to itself. Automakers including General Motors, Hyundai, Volvo, Zeekr, and XPeng have all invested heavily in large-scale die-casting systems. XPeng, for example, has already introduced a massive 16,000-ton casting machine as manufacturers race to adopt similar production methods. But while competitors focus on catching up, Tesla is already preparing for its next major leap. Instead of stopping at 20,000 or even 30,000 tons, Elon Musk has revealed an ambitious goal: a gigapress capable of delivering an astonishing 50,000 tons of clamping force. When Elon Musk mentioned the possibility of a 50,000-ton gigapress, many people immediately questioned how such a massive machine could actually be built. Where would Tesla install equipment of that size? How long would the setup process take? And perhaps the biggest question of all, how could one machine create major structural parts for multiple vehicles at the same time? It sounds almost impossible, but according to Tesla's vision, that is exactly what makes the idea revolutionary. Once a machine of this scale enters production, the goal is not simply to make manufacturing faster. Tesla wants to create a factory system that operates at a speed beyond what human workers could achieve. Every step, from injecting molten aluminum into the mold to cooling, removing, and inspecting the finished component, would happen through a highly automated sequence with minimal interruption. The expected production cycle could become extremely short, allowing large vehicle structures to be produced in only a few seconds. Instead of resembling a traditional automobile factory, Tesla's future production line would look more like a high-speed electronics manufacturing facility. The entire process would move so quickly that human access near the production area would become extremely limited. At first glance, a 50,000-ton gigapress may seem completely different from today's 6,000-ton or 9,000-ton machines. However, the basic idea remains the same. The difference is the enormous increase in scale, speed, and precision. Everything begins with the aluminum material. Tesla can use both fresh aluminum ingots and recycled aluminum from previous castings. These materials are placed into a furnace heated to approximately 850 degrees C until the metal becomes fully molten. After melting, unwanted surface impurities are removed. The liquid aluminum is then transported through heated pipelines into a sealed holding furnace, where it remains at a controlled temperature between roughly 750 degrees C and 850 degrees C until it is ready for the next casting cycle. The system uses two separate furnaces. The first furnace is responsible for melting the aluminum at extremely high temperatures, while the second electrically heated furnace maintains the molten alloy at the ideal temperature before casting. However, maintaining temperature alone is not enough. The environment inside the holding furnace must also be carefully controlled. Tesla uses nitrogen gas to reduce the possibility of the molten aluminum reacting with oxygen and creating unwanted oxidation. This creates a more stable environment for maintaining the quality of the alloy. To further improve the purity of the aluminum, additional processes are used, including argon gas treatment, rotary degassing, and filtration systems. These methods remove trapped gases and unwanted particles, ensuring that the final material meets strict quality standards. Only after these preparation steps is the aluminum ready for the actual casting process. Before each casting cycle begins, the mold itself must be prepared. A robotic system applies a thin layer of lubricant across the mold surface. This helps the finished component separate smoothly after the aluminum has cooled, similar to applying oil before baking to prevent sticking. After lubrication, the system creates a vacuum inside the mold to remove trapped air. This allows the molten aluminum to flow more effectively into every section of the cavity. The prepared aluminum then moves from the holding furnace into the gigapress injection chamber. A powerful piston, also lubricated before each cycle, pushes the molten aluminum into the mold with enormous force. This high-pressure injection is what allows the machine to create large, complex structural parts as a single piece. Once the aluminum enters the mold, it begins to cool and solidify. The waiting period is short, but every moment matters. The newly formed casting exits the machine at a very high temperature, close to 400 degrees C. The process does not end there. The hot component is immediately transferred into a cooling system where its temperature is rapidly reduced to around 50 degrees C. This rapid cooling process does more than save time. It also helps reduce certain manufacturing defects and improves the final mechanical properties of the aluminum structure. At the same time, the mold goes through its own preparation cycle. After opening, it is cooled to the correct temperature, cleaned by automated systems, and prepared for the next casting operation. Because every step is carefully synchronized, another production cycle can begin shortly after the previous one finishes. Any leftover aluminum from trimming the finished component is collected and recycled back into the melting process, helping reduce waste. Before a casting is approved for vehicle production, it undergoes advanced inspection, including X-ray testing. This allows Tesla to examine the internal structure of the part and detect problems that cannot be seen from the outside. However, one of the greatest technical challenges happens during the injection stage itself. When molten aluminum is pushed into a closed mold under extreme pressure, the machine must generate enough clamping force to keep the mold securely locked together. Without sufficient strength, the pressure could separate the mold and damage the entire casting process. This is why a 50,000-ton Giga Press represents such a significant engineering challenge. According to Elon Musk, achieving this level of manufacturing speed requires much more than simply building a larger machine. Tesla must create an entire ecosystem around it, including advanced cooling technology, intelligent mold release systems, and artificial intelligence-based inspection methods capable of checking every component in real time. Bringing all of these technologies together at such a massive scale would represent something the automotive industry has never attempted before. The importance of the 50,000-ton gigapress goes far beyond creating a faster way to build vehicles. It represents a complete change in the way future factories could operate. For more than a century, automobile manufacturing has followed a similar approach. Thousands of individual parts are produced separately and then connected together using welding, bolts, brackets, rivets, and other fastening methods. Tesla is taking a completely different direction. Instead of assembling a vehicle structure from hundreds of separate pieces, the company aims to create much larger unified sections through advanced casting technology. This approach could transform a complicated assembly process into a much simpler and more efficient one. A structure made from fewer connected parts offers several advantages. It can improve rigidity, reduce possible weak points, and allow the entire chassis to behave more like a single strong piece rather than a collection of smaller components joined together. These improvements can translate into real-world benefits, including better driving stability, improved comfort, stronger crash protection, and more predictable energy absorption during accidents. As vehicles become increasingly autonomous, manufacturing consistency and structural reliability could become even more important. However, Tesla's factory revolution does not stop with the Gigapress. The company is also targeting another major challenge in vehicle production, the paint shop. Painting a vehicle is one of the most expensive and time-consuming parts of manufacturing. Traditional paint facilities require large amounts of factory space, consume significant energy, and add multiple steps to the production process. Instead of simply making paint shops more efficient, Tesla appears to be exploring a more ambitious idea, removing the traditional painting process completely. According to Tesla patents, future vehicle panels could potentially include their final color directly during the manufacturing stage. Rather than creating a body panel first, and sending it through several painting and coating stages afterward. The material itself could be produced with the desired appearance already integrated. This would allow a finished panel to come out of the manufacturing process already colored, eliminating several additional production steps. Recent Cybercab prototypes have shown changes in their surface appearance compared with earlier versions, suggesting Tesla may continue improving its approach to vehicle finishes. If this technology becomes practical on a large scale, the impact could be significant. Traditional paint facilities require massive buildings, expensive equipment, and complex environmental systems. Removing or reducing this stage could save factory space, lower energy consumption, reduce costs, and simplify vehicle production. Combined with the Gigapress, Tesla's manufacturing strategy represents a completely different philosophy. Instead of building cars through thousands of separate operations, the company is moving toward highly automated factories where fewer machines perform larger, more intelligent tasks. The goal is not just to manufacture vehicles faster. It is to redesign the entire process of how vehicles are created. If Tesla succeeds with this approach, future factories may look very different from the automotive plants we know today: smaller, faster, more automated, and closer to the production methods used in advanced electronics manufacturing. The Gigapress is not simply a giant machine. It represents Tesla's broader vision of making vehicle production simpler, more efficient, and capable of scaling to levels that traditional manufacturing methods may struggle to achieve. As the automotive industry moves toward electric vehicles and autonomous transportation, manufacturing innovation could become just as important as battery technology and software. And Tesla's biggest advantage may not only be the cars it builds, but the factories that build them. And that brings us to the end of today's episode. Tesla's Gigapress is more than just a powerful piece of factory equipment. It represents a new approach to vehicle manufacturing, one focused on automation, speed, simplicity, and efficiency. Whether Tesla's vision becomes the future standard for the entire automotive industry remains to be seen, but one thing is clear: the way cars are built is changing faster than ever before. What do you think about Tesla's next-generation manufacturing technology? Could massive casting machines and fully automated factories completely transform the future of automobiles? Let us know your thoughts in the comments. Thank you so much for watching and supporting our channel. If you enjoyed this video, don't forget to leave a like, share it with others, subscribe to the channel, and turn on the notification bell so you don't miss the latest updates about Tesla, electric vehicles, robotics, and future technology. We'll see you in the next video. Until then, take care and stay safe.